everyone, I'm Teacher Raccoon. Today we are going to have a look at Gigo Product 7416 Robotic Smart Machine. This set is focused on connectivity between models and smart devices. After connection, we can write a program to remotely control the models. Okay, now let's take a look at some information from the box. First, we can see that there is an A+ symbol in the lower left corner. This means it is more suitable for children 8 years and older. The reason for this is because some of the programs and models are a bit complex for younger players. It is really not recommended for children under 8. We can see here where it says 230 pieces. This means there are 230 components in the set. So we suggest that when you open the box up, you take out the manual and run a quick inventory check. Now, looking in the lower right hand corner, this number 8 means that there are 8 models that we can make from the instructions. All the models are included in the manual. Of course, it is fine if you want to make your own models. In fact, it's great. Over here is a QR code. If you scan this QR code using your phone, it will direct you to Gigo's official website. There you will be able to see all the models and some related videos. Okay, now let's open this up. Here's what we will find inside. There's the manual. And there are the components from the C-block system. Inside there are 4 packages. Let's look more closely at the most fundamental components. 2 motors. This is a 40X motor. This is a planetary motor. And next, this part here is your Bluetooth receiver. With this receiver, you can connect your phone to the device. There are 3 battery spaces in the Bluetooth receiver, so we'll need 3 batteries to make it function. Just a quick reminder, there are no batteries included, because all batteries have an expiration date. I have 3 alkaline batteries ready here. We'll be using alkaline batteries because we want to ensure the device is working optimally. Now, let's run a quick test on the sensors and motors. In order to control them, we first download the app. This enables a connection with the Bluetooth receiver. The download page is on page 6 of the manual, and you'll find that there are 2 QR codes, one for Android and another for iOS. For this demonstration, we'll use the Android version. Open the QR code scanner and scan it. After scanning the QR code, you should find yourself at the Gigo section of the Google Play Store. Because I have downloaded it, the screen shows open. If you haven't downloaded it yet, click download. The app is called Gigo Smart Machines. If you use Android, you must run Android 4.3 or later. iOS devices must be running iOS 8.0 or later. Also, your device must support Bluetooth V 4.0. to avoid compatibility issues. Now, let's introduce the motors and the sensors. First, let's install batteries into the Bluetooth receiver. After the batteries are installed, turn it over. There is the blue flashing, which means it has normal power supply. If the device is idle for a period of time, it will go to sleep. If you want to wake it up, just shake it like this. Shake it to wake it. Okay, there are 3 sockets here, where we plug in the connectors. Now let's install the sensors. This is an ultrasonic sensor. One eye sends out an ultrasound signal and the other eye receives ultrasound signals. This means even at night, it can detect whether there is an object in front of it and how far away it is. Look at this connector. You can see it is not a full circle. There's a small flat edge here. This is to stop the connector being inserted incorrectly. There's also the same design on the socket side. Make sure the ends align correctly. The sensor must be inserted in the middle socket. Again, make sure the ends align correctly. And the left and right sockets are reserved for these 2 motors. Those are inserted the same way, with a connector and a socket. Now, that is most of the setup complete. If we want to remove this connector, we can use the pack remover, NB. It plugs in like this and comes out easily like this. After you've downloaded the app, you'll be able to see this icon on your device. Before clicking it, please remember to enable Bluetooth on your device, because the phone connects the model via Bluetooth. Now, enable Bluetooth. After turning on Bluetooth, you can click the Gigo Smart Machines app. It'll take a second to start up. The welcome screen looks like this. There's a symbol that is always flashing in the upper left-hand corner. This is telling you that the Bluetooth model is searching. This is telling you that the Bluetooth has not connected yet. If it connects successfully, you'll see a change in the flashing icon, where the flashing becomes a constant light and does not flash. Also, you hear the motor run for 1 second as the test. Great! This means the Bluetooth receiver and the device are successfully paired. If you cannot successfully make the connection, you can turn off the app and turn it on again. Or try turning off Bluetooth and enabling it. Or unplug the Bluetooth receiver and plug it in again. The screen is the remote control mode. Here you can see the two slider controls. This left arm controls the motor A. It controls the motor connected to the left socket. If we slide the slider up, and the motor will spin clockwise. Slide it down and the motor will spin counterclockwise. The right slider functions the same way. Slide the slider up and the motor will spin clockwise. Slide it down and the motor will spin counterclockwise. Here comes the ultrasonic sensor. Now check the middle part. Can you see the circular ring that looks like a radar? The green circle corresponds to the ultrasonic sensor. This shows the distance of any obstacle in front of your sensor. Suppose it has no obstacles in front of it. This means the green circle will be large. If an obstacle comes into range and gets closer, then the green circle will get smaller and smaller. Currently, the green circle is small. If you pull the obstacle away from the sensor, the green circle becomes larger. That's all the part for the motors, sensors, and remote control functions. Now have a look at the programming mode. To enter programming mode, click the gear button in the upper right corner of the remote control mode. After clicking, you'll find 16 programs. Most of them are the default programs for your base model. Because you have 8 models here, it contains several default programs that look like this. Of course, there are also blank programs for experimentation, like program 8, which is deliberately left empty. Try using a blank program to test the device. How can we make a program? First, look at the gray column at the top. Click on the button plus button, and there are options appear from left to right, which are motors, nodes, and rest. Let's try something with motors. You can see a blue gear and a red gear. Blue gear is motor 1, red gear is motor 2. The blue gear shows motor 1, which you connect to the left socket. The red one is motor 2, connect to the right socket. If you think you might forget which is which, then you can use blue and red pens to make a small mark, like I have. This way, when you are choosing motors 1 or 2, you won't get confused. Now we can see clearly which is which. Now, let's write a program. Both motors have a value range between +4 and -4. We can change the value number. This number represents speed. Plus and minus represent the spin direction. Plus means the motor spins clockwise, minus means the motor spins counterclockwise. For example, the left motor, a 40X motor, is spinning clockwise at full speed. And the right one is reversing at minimum speed. This part also lets you set the duration of motor spin. I set this one to spin for 1 second. Check the checkbox to save the program. Now this program has all the information it needs. Basically, the motor's program is complete. But how do we actually make it run? To do this, press the triangle button on top. Okay, you can see the two motors run for 1 second. After a button is pressed, one turns clockwise and the other turns counterclockwise. One turns at full speed and the other turns at minimum speed. This concludes the introduction to motor programming. Okay, now let's look at sound. If you click the note button, you can see Do, Re, Mi, Fa, Sol, La, Si. These are the tones you can generate to make an arrangement. Here you will also be able to set the duration of the sound. This is where you can arrange a song. Let's see if we can make it sing Twinkle Twinkle Little Star. The melody is Do Do So So La La So Fa Fa Mi Mi Re Re Do. So the melody is quite simple, but we have to remember timing. So we'll make each tone last about 0.5 seconds. Between songs, make it pause for 1 second. This is a chance to use the last program we have available, the stop program on the right. As the name suggests, you can make a program stop for a few seconds. If we put it in the program will stop. Make it pause for 1 second. Now we can write the second part. Right, now it's all set up. The notes program is complete. Press the go button and see what happens. Don't forget the sound are played from your phone or other devices. Make sure that the media volume of your device is turned up. Now let's play it once. You can hear there's 1 second pause. If you practice with this and use the sound program a lot, then you and your child will be able to have fun composing. Next up, we can see the value of an ultrasonic sensor and where it can be used in programming mode. After the play icon is touched, a white number appears in the upper left-hand corner that will tell you the sensor value. This value is not fixed. It represents the distance between the sensor and any obstacles it sees. Right now, there is nothing in front of my sensor, so the number reads larger than 100. If you use your hand as an obstacle in front of the sensor, the value changes. The device gives it readout in centimeters, and you can see it drop like this to around 25. That means there is an obstacle, approximately 25 cm away from the sensor. Now, check the indicator line below. Did you see that the indicator line is divided into 3 areas by 2 orange markers? These are blue, green, and purple areas. These 3 areas represent thresholds or cutoffs that can be used in coding. This also means you can use the value of your sensor to decide which program will run, according to the color segment and use. Let me show you. Here, we can see the blue area to represent the range 0 to 30 cm. This means that when the sensor sees something in the 0 to 30 cm range, the program motor 1, spin clockwise, speed plus 4 will be triggered. And the green area we can assign to the range 30 to 100 cm. When the sensor sees something in the 30 to 100 cm range, the program will play a sound. And the purple area we can set to greater than 100 cm, and then the program motor 2 reverse will run. Now, the program is all set up. Let's press the play icon. The gray area is the main program that runs once you press the play icon. If there is no program in the gray area, it will automatically run the programs below. There is a loop icon on the left that looks like a circle. If we check this checkbox, the program will repeat. If we don't check the checkbox, the program will run once then stop. After we press the play icon, we'll be able to see how the program functions. My hand is right in front of the sensor, so motor 1 starts to spin. When I pull it away, motor 2 starts to spin. Because there is no obstacles detected, this means the distance to an obstacle must be greater than 100 cm. Now you know how to use the sensor value to trigger different actions. That is how the ultrasonic sensors works with programming. The value above the indicator line can also be adjusted, so the range doesn't have to be 0 to 30 cm or 30 to 100 cm. The markers defining the range can also be adjusted. For example, try setting it to 0 to 15. You can also add more range markers. To do this, first press the second icon from the left. This adds a new marker. As the number of markers increases, so does the number of the areas. So you'll see that in the indicator line, there's a new red area on the right. If we go to the next page, we can see the 4th area, the red area. We can add up to 8 range markers for a total of 9 areas. When you have everything set up the way you want, to save it, touch the disk icon on the right. Touch this to save the program. If a program is not what you wanted and you want to revert to the last saved version, simply tap Revert to Save. Revert is the third icon from the left, and it will revert to the previously saved program. Because we didn't save any program, it will revert to the default. Okay, next, if you want to see other programs, click the storage box icon to the right of the play icon. This way, you can remove to a different program directly. For example, click 1 to switch to another program. Okay, when you want to delete a program, press the trash can icon on the left. When you want to leave programming mode, press the door icon. A window will pop up asking you if you are sure. Just check the checkbox. And then we are back in the remote control mode. Now we'll build a mechanical T-Rex. Before getting started, let me share a tip with you. You have all the assembly steps right here, from the very beginning to the complete model. Okay, we only need to pick the components required for each step, like this. So if we need this component, we just search the bag and grab only those parts from the bag. Okay, now we can add the decorate shell, and the model will be completed. And here is a kind of special component. It is a flexible drive shaft. The flexible shaft has the same function as the hard shaft. Its function is to turn the gears of model and to transfer the energy. Furthermore, the middle part of the flexible shaft is soft, so it can be bent to make a U-turn. Therefore, the flexible shaft can be used in more situations on assembly. It has less restriction than the hard shaft. Your creativity has no limits. Now we've made a mechanical T-Rex. You can see how it operates in the remote control mode. The motor icon next to play planetary motor, which can make a T-Rex walk. And this 40X motor needs to be installed correctly according to the instruction manual. Otherwise it may be off balance when it walks, swinging the same arm and leg together. Motor 2 can control the jaws and mouth of the T-Rex. Each model in the manual has a default program. The manual will tell you which program to use. Here, we see that the T-Rex default is 5. Tap on program 5, and you'll see the example program for the T-Rex. After we tap the play button, we'll see the program run. First, the upper part, then the lower part. As mentioned before, the model makes different decisions based on the distance value. Even when the rule is at the lowest level, you can still change the program. That's all for the T-Rex. We can use the ultrasonic sensor and the motors to do more, and make other creative models. Like this, it's an alcohol sprayer. The scientific principle is quite simple. Use the 40X motor here, and a simple linkage mechanism. The motor turns, making the linkage move. To press the alcohol spray, it can help with disinfection. The program is simple. Set the ultrasonic sensor to a range less than cm. Now, if it detects an object within 7 cm, like hands for example, the motor will move like linkage to press the bottle and spray out the alcohol. Okay, let's try it. It's like this. With this automated alcohol spray, disinfection is easy, but the prototype model can also be used in remote control mode. It just needs some adjustment. First, remove the ultrasonic sensor. Pour out the alcohol, pour in some water. Now, if you have some plants in your house, you can put this model behind the plants and water them with just one finger. That's how an alcohol spray becomes a plant watering device. That's all for today unboxing video. I'm Teacher Raccoon. See you next time. Bye.